Hello, today we're going to be starting a new type of function that many of you have never seen before. The new function we're going to be looking at is what we call a logarithm. A logarithm is a very, very special type of function that we're going to be looking at for the next several weeks. This is the first type we're going to be looking at is what we typically reference as a common log. A common log is defined as the inverse of the exponential function y is equal to 10 to the x power. It's the inverse, just the same as if we see a plus or a minus and we know they're opposites of each other. Same as multiply and divide, same as something squared in the square root of a number. If we have 10 to the x power, the opposite of that is what we call a logarithm. And so how a logarithm would technically be written is if we have if we have y is equal to 10 to the x, then log of y is equal to x. If you note, our base from the exponential function is no longer even listed here. And the second thing I want to notate is since x is an exponent, x's location is an exponent in the equation, log of y is equal to an exponent, so that's going to make log of y also an exponent. What that's going to mean is exponent rules are going to apply. So let's take a look at a pretty basic function. We've got y is equal to 10 to the x. If I asked you to complete an xy table for this, let's say 0, 1, 2, 3 is x. Let's take a look at how that would come out. So 10 to the 0 power would be 1. 10 to the first power would be 10. 10 squared would be 100. 10 cubed would be 1000. So what happens if we did 10 to the log x power? Now you guys might remember when we did inverse functions, we said that the two would cancel each other out, and it's going to hold true here, and 10 to the log of x power would just be x. So same deal over here on the right. If I was looking for y is equal to log of x, so x is 1. So what that's going to tell me is 10 to what power is equal to 1? In this case, that would be 0. 10 to what power is equal to 10? In this case, it would be 1. If x is 100, it would be saying 10 to what power is equal to 100? And in this case, it would be 2. If x is 1000, we would be asking ourselves 10 to what power is equal to 1000? And that would be 3. So if I have a log of 10 to the x power, just like what happened on the other half of the table, a logarithm is the inverse of the exponential. So what they will do is they will cancel each other out. So if we were to look at just a couple of basic examples, I have 10 to the fourth is equal to 10,000. So if I wanted to rewrite this as a logarithm, I would have log of 10,000 is equal to 4. And that's because 10 to the fourth power is equal to 10,000. A logarithm says if that's my result, what got me there? So on our next function, or our next example, I have 10 to the negative 1 is equal to 1 over 10. And so in this case, log of 1 over 10, so 10 to what power got me here? And my answer here would be negative 1. So let's go ahead and take a look if I wanted to take a logarithm and go back to being an exponential. So I've got log of 100,000 is equal to 5. So I need to remember where my exponent is. In this case, my exponent would be the 5. And so I would have 10 to the fifth power, and we know 10 to the fifth power would equal 100,000. On our next example, we have log of 1 over 100 is equal to negative 2. So what that's telling me is 10 to the negative 2 power is equal to 1 over 100. So they go back and forth very, very easily. Now if we're actually trying to evaluate each logarithm, so we're trying to figure out what exponent here actually gave us these values. So on A, we've got log of 1,000 would be equal to 3, because 10 to the third power is equal to 1,000. So on part B, we have log of 1 over 10,000. So we're trying to figure out what exponent with 10 would give us 1 over 10,000. In this case, we would end up with -4. So let's just kind of look at some real easy tips on how to help us evaluate these. For the common log, now this is only for the common log. When we get to other bases, because 10 is not the only base that we're going to come across, it can get a little bit more tricky. So the first thing that we're going to look at is make sure you keep your items as a fraction, like on example B, because it's going to make your life easier. Second thing, count the zeros. So on example A, where I had log of 1,000, I had 3 zeros. Answer's 3. On part B, I had log of 1 over 10,000. I had 4 zeros. But here's the catch. The answer is negative if it's still a fraction. Okay, pretty easy when working with the common log. And another way you can kind of do it is if you actually just made a table where you know 10 to the 0 power is equal to 1. So if I was trying to get smaller, I would have 10 to the -1. Like we discussed in the exponential function, we would get smaller. So I'd have 1 over 10. 10 to the -2 would give us 1 over 100. 10 to the -3 would be 1 over 1,000. And 10 to the -4 would be equal to 1 over 10,000. And so, since that's what I wanted, my answer is that exponent right there. And so sometimes that is what you're actually going to have to do, where you're actually going to have to work it out and just kind of think about it for a moment. Okay, so since these things are exponents, we have to just kind of remind ourselves of some basic exponent rules. So if I had a to the m power times a to the n power, you might remember that what we're supposed to do in a case of multiplying with exponents is that we're supposed to actually add the two exponents together when we put them side by side. Now, so if I had an example here, if I've got x squared times x to the fourth, x squared would be represented by 2x's, x to the fourth would be represented by 4x's, which would give me a total of 6x's overall. If I have a to the m over a to the n, what that would tell me to do is I would want to subtract the two exponents. Just a little Algebra 1 kind of reminder. If I had x to the fifth divided by x squared, I would have 5x's on the top, 2 on the bottom. 2 of them would end up canceling out, leaving me with 3x's behind. The last rule is if I have an exponent and I take that exponent to a power, then what I'm supposed to do is I'm supposed to multiply the two exponents together. So just a basic example, if I have x squared and I cube that, that would tell me I have 3 groups of 2x squareds. And in this case, that would give me a total of 6x's when I count them all up. So that's going to be kind of going along with what we're going to be looking at next. We have 3 basic log properties that we're going to be looking at. All 3 of them go back to the previous page. So our first one is what we call the product rule. If I'm multiplying with logarithms, since these are exponents, multiplying can really be translated to addition. The second one is what we call the quotient rule. The quotient rule is if I have a log of one number divided by a second number. How that's going to translate is just like the last page, since they're exponents. When you're dividing with exponents, that means you're really subtracting with those exponents. Our third rule is what we call the power rule. So if we have a logarithm raised to a power, if I have a power raised to a power, that means I'm really going to be multiplying with those two items together. Now there's 2 types of instructions that you're going to start seeing with these properties. The first is what we call expand. Expand, we're going to make the equation bigger. So we're going to be given one logarithm and be asked to rewrite it into several multiple logarithms. The second type of item that we're going to be able to see is instructions that tell us to condense. And this is where we take several logarithms and put them all together and make it smaller into only one logarithm. So it's kind of a work backwards. The last thing I want to say about that is condense is really the ones that you're going to see a lot of in this course. And that's because it's very important for evaluating as well as solving a logarithm. Okay, so let's look at a couple of actual examples. Our first example is if I have log of x minus log of 7 and I'm wanting to condense it. So I'm only allowed one logarithm in my answer. Now I see that I've got subtraction in the middle. I'm looking at a difference, and I know the difference comes from the quotient rule. So the quotient rule means I'm really taking these two and dividing them. Now on my second one, it's a little bit more complex because I have two items here. The first, I'm only allowed one logarithm, and I know that a plus sign means I'm going to be multiplying these two with a product. The second is I have a 2 in front of my log of x. So that's going to tell me my x is going to be squared. So I'm going to have log of x squared times y. Now on part A and part B down here at the bottom where I'm asked to expand, you really need to be looking at how many terms do I have here. On part A, I have 3 terms. I've got my 5, I've got my x, and I've got my y to the 4th power. So when I'm looking at these, I'm going to have 3 different logarithms. My first one, I'm going to have log of 5. Now I know that 5 and x are a product, so I'm going to put plus log of x. Now the last thing I know is I've got y to the 4th power, that's a product with these two, and so I also have plus log of y. But on this one, I have an exponent as well, so that exponent would make this 4 logs of y. Now, the last example on this, I've got to expand the logs, I'm looking at log of x divided by y cubed. So the first thing I have here is my first item, which is just log of x. Now since I'm dividing with x and y cubed, I'm going to use a subtraction, and I'm going to be also looking at that exponent. So that exponent will move to the front of the log, and I'll have minus 3 log of y. Now, like I said a moment ago, condensing is very, very important to evaluating. So the first thing I would look at doing here on A, B, and C is to condense before I evaluate. So on part A, the first thing I would look at, I see that there's a plus sign. That means I'm really multiplying with the two values. So that tells me I've got log of 2 times 5. 2 times 5 gives me 10 though. So 10 to what power is equal to 10? The first power. So that would be my answer, is the first power. So in part B, I have log of 5,000 minus log of 5. So when I'm looking at this, the first thing I would do is condense. I would change that to a quotient. Log of 5,000 divided by 5. 5,000 divided by 5 tells me I'm looking at log of 1,000. So 10 to what power gives me 1,000? I've got 3 zeros. That's telling me I'm looking at the third power. So on part C, I'm going to condense. So the first thing I would do is change this to log of 5 squared times 4. I would want to simplify order of operations. 5 squared would give me 25. 25 times 4 would give me log of 100. 10 to what power would give me 100 would be the second power, and that would be my answer. Okay, what I would like for you to do is I would like for you to go ahead and try 2, 3, 4, and 5 on your own. Push pause, and then go ahead and try them. I'll put the answers up in just a moment. So just go ahead and push pause, and then try these.